Hello everyone, mathematics presentation, laws of exponents by Sir George. We cannot change the laws, but in maths we can play with the given question up until we are able to apply the law to simplify whatever is provided to get to the answers. Now we are going to look at the laws of exponents and the equation involving exponents. In the other videos we'll look at the listed below laws of sets and the operations that involve sets. Now the laws of exponents. The number one law, a to the power of m multiplied by a to the power of n is equals to a to the power of m plus n. Now, the important part from this law is that the base has to be the same when you are multiplying, and in the end you add the powers. This is what the law is saying. For example, 3 to the power 2 multiplied by 3 to the power 2, you end up having 3 to the power of, you add the powers, that is 2 plus 2, which is 3 to the power 4. When simplified, it's 81. Now the second law here says a to the power of m divided by a to the power of n is the same as, okay, this division, remember maths has different ways of writing the same thing or saying the same thing. This is the same as a to the power of m divided by a to the power of n. We need to read and understand this language. That's how it can be helpful for us to answer questions correctly without any challenges. Now when you are dividing, you subtract the powers, but the power of the numerator subtracts the power of the denominator, hence m minus n. Now for example, 5 to the power 4 divided by 5 to the power 3, the powers will subtract. The power of the numerator here is 4, the power of the denominator is 3. Hence if you subtract, you get 5 to the power 1, which is just 5. Now a to the power of n raised everything to the power of m is the same as a to the power of m multiplied by n. So when you are given a scenario like this, the powers will multiply. For example, 2 to the power of 3, 2 to the power of 2, everything raised to the power of 3 is the same as 2 to the power of the product of the powers that are provided, 2 by 3, which is 2 to the power of 6. In the end, you get your 64. Now, a, b to the power of m, when you are multiplying, be it the numbers or the variables, then they are raised to a certain power. Every term inside this should be raised to the power. It has to be affected by the power a to the power of m and b to the power of m. Hence the law. For example, 2a to the power of 3 is the same as 2 to the power of 3 raised to 2 to the power of 3 multiplied by a to the power of 3. Then you end up getting your 8a to the power of 3 here. Now another law says a to the power of m over n is the same as, what you have as the denominator comes here as the nth root of. Now what you have as the base is what comes here under the square root. What you have as the numerator here comes as the power. Remember the meaning of equal sign. It means what is on the left is exactly the same as what's on my right. Now it means I can read this law from right to left. This time I read it from left to right. So we need to know that it still applies. For example, 8 to the power of 2 over 3 is equals to, what I have as the base goes under the root. What I have as the denominator of the power comes here. What I have in the end comes as the overall power outside. So in the end, if you take the cube root of 8, you get 2, but raised to this other 2, you get this 4. Then a to the power of 0 is equals to 1. This is just saying any number raised to the power of 0, you get 1. For example, 1000 to the power of 0, the answer is 1. Now another law says a to the power of negative n is the same as 1 over a to the power of positive n. If it is negative here, it is positive here. For example, 5 to the power minus 1 over 3 is the same as 1 over 5 to the power of positive. It was negative here. When it comes down here, it becomes positive. Then this is the same as 1 over 125. In all of the examples, in the end, I was simplifying my final solutions. We cannot leave answers like this if we know how to get to a further step. Now, after doing this, what types of questions do they ask in the exams? Example, simplify the following. The word simplify, it means reduce or do something up until there is nothing else that you can do. So this is what this example is telling us. Simplify the given question. A to the power of 4, b to the power of 2, c to the power of minus 3 divided by. Yes, we have listed the laws. We have understood them. But what is happening here? It involves division. Which of the laws am I probably to call? I see the law of division here. If I have the same base, we know that the powers will subtract. So for a, the power of the numerator will subtract the power of the denominator, hence 4 minus 6. For b, I have power here 2 subtracts the power of the denominator, which is 2 minus 1. For c, it's minus 3 minus the power of the denominator, which is minus 2. Now we simplify it further to say a to the power of minus 2 if you get here, b to the power of 1, which is just b, c to the power of minus 5. But at this stage, there is also still something else that I can do to this expression. I can say b, remember this, a to the power of negative n is the same as 1 over a to the power of positive n. So everything that I have with a negative power can come down as the denominator. Hence, you see a squared and c to the power 5 coming down. b as a positive power, it remained. At this point, you have simplified. There is nothing further you can do here. You have satisfied the requirements of the question, simplify. Now, we also have another types of questions that they ask. Example 2 here. Given that the square root of 10 is equals to 3.162, find the fifth root of. It is important to be able to understand and read the language. Find the fifth root of 316.2. Now, when a question says given that, it means the provided information you are going to, or you are supposed to use it. Now, and this is what you are looking for. So to simplify this, fifth root of, the question normally says without using a calculator. So how do you go about it? The fifth root of 316.2 is the same as, if we are to remember the law, a to the power of m over n is equals to the nth root of a, everything raised to the power of m. Putting that into practice, reading it from left to right, what I have here is my n. It comes down as the denominator, hence I have the 5. What I have outside, if we are to put it exactly as the law, this will be raised to the power of 1. So my 1 becomes the numerator. We discussed it when I gave the law. Then the 316, which is under the root, becomes the base. So this is how I formulated this. The whole idea here is a game of taking the given maths expression to where I understand and I am able to solve it without needing a calculator at all. Now, we have given information. Square root of 10 is equals to 3.162. How do we put that into play is another thing. So 316.2 can be written as 3.162 multiplied by 100. This is exactly the same as this, hence the meaning of the equal sign here, hence the existence of the equal sign in this. Now after this, the reason why I brought in this type of writing is because I want to find a way of using the provided information given that I needed to use that. So from there, we know that 3.162 is the same as square root of 10. So I substituted here, 100 comes down, the 1 over 5 is still coming down. Now, from the laws, you know that square root of a is the same as a to the power of half. So this is the same as 10 to the power of half multiplied by 100 can be written as 10 to the power of 2. My power here still remained 1 over 5. Now, when we have this case, remember our law, a to the power of m times a to the power of n, we have to add the powers. Since the base is the same, that's exactly what happened. It's 10 to the power of half plus 2. We added the powers here. The 1 over 5 is still coming down. I haven't touched it yet. Now from this, when I have a to the power of m, then everything raised to the power of n, we said the powers will multiply. So if you simplify here, you are going to get 5 over 2. Then with this 1 over 5, the powers will multiply. If you multiply, the 5 and the 5 will cancel. In the end, you remain with 10 to the power of half. But 10 to the power of half can be written as square root of 10. So square root of 10 is the one which is provided. So I don't need to punch a calculator again. I just have it. It's here as square root of 10 is the same as 3.162. So at this point, you have simplified, you have solved the required. It started by you being able to read the question and identify that the laws of exponents are involved and exactly selecting the correct ones to apply and answer the question. Now, questions involving exponents, solving equations involving exponents, you are given a simple one here. Solve the equation for 4 to the power of x is equals to 32. You need to be able to read this. 4 to the power of x. Now, most of you guys, you end up having, you change this question to 4x equals to 32. That is wrong. It's 4 to the power of x equals to 32. Now, from what we just learned, there is a way of writing 4. I can write 4 as 2 to the power of 2, then raised to the power of this x. Is the same as, we can write 32 in terms of 2. Is the same as 2 to the power of 5. Now, the powers will multiply here, so it's 2 to the power of 2x is equals to 2 to the power of 5. Now we are using the law a to the power of n, everything raised to the power of m is the same as a to the power. We multiply the powers at this point. Now when the bases are the same, remember the equal sign means what's on the left is exactly the same as what's on the right. So if I have a 2 and I have a 2, the bases are equal. So for this equal sign to hold, this has to be the same as this. So the powers must be equal as well. As bases are the same, the powers must be equal. So from this, you just created a linear equation, a linear expression that you can solve. So solving for x, you divide both sides by 2. Hence, x is equals to 5 over 2. This is how I reached this final solution. Now, in the exams, again, equations involving exponents, solve the equation 2 to the power of 2x plus 4 to the power of x plus 1 is equals to 80. Now, at this point, the idea is, from what I have learned in the examples I've seen already, how do I simplify this? At one point, I might need to arrive at the same base. When the bases are the same, the powers are equal, but I still have another operation here, plus. How do I deal with that? So 2 to the power of x, 2 to the power of 2x, there's nothing to simplify so far. But here, I can write 4 as 2 to the power of 2, then the power x plus 1 is there, equals to 80. 2 to the power of 2x plus. We can multiply the powers. We said that this is now you being tested to multiply a monomial by a binomial. Those concepts will always connect each other. That's how it is in maths. The ideas, the concepts will connect, and you always find a way of using each one of them. Now 2 to the power of 2x plus 2, we now have it. Now from this, if a to the power of m times a to the power of n is the same as a to the power of m plus n, I can reverse that and read it in reverse. The law that I'm referring to is this one. So I can read it from right to left. We discussed it. Now back to the question that we are dealing with. We are saying, I read it from this. It can be changed from here to 2 to the power of 2 multiplied by 2 to the power of x. The whole idea is taking down this into what I can understand. Now this is the same as 4 to the power of 2x, 4 by 2 to the power of 2x with another 2 to the power of 2x here is equals to 80. It's an equation. I have only one equal sign. And never also at one point put equal signs here when you have another one this side. Now from there, I can add this. This is like a banana plus 4 bananas. That's you get 5 bananas. So only that my banana is 2 to the power of 2x, or apples, whatever fruit you choose of. Now, after having 5 to the power of 2x, I can divide. The job here, find x, it is involving the backbone of maths, subject of formula. In the end, I need to make x the subject of the formula, which means I need x to be on one side of the equal sign and the rest to be on the other side. So the process involves some reverse of operations. When I am multiplying, the reverse there to change this, I have to divide. So you divide both sides by 5, you get 2 to the power of 2x is equals to 80 over 5, which is 16. Now if I have 16, I can write this as 2 to the power of 2x is the same as 16 can be written as 2 to the power of 4. Now the bases are the same, the powers are equal. So 2x is equals to 4, divide both sides by 2, you get your x equals to 2. Now after this, you can test yourself with this simple exercise. The idea is not only reading only the laws and say, I understand maths. The idea is on exposing yourself to several kinds of questions that can be asked and be able to solve and apply the specific law that can get us to the correct answer. So at this point, you can test yourself, play with the simple exercises, and also find more from past exam papers, practice with them, and master and understand the idea of applying a concept to a given question. I thank you. We'll continue with the laws of sets. Please subscribe and pay attention. Continue learning and practicing. Understand the language. See maths as a tool, not as a punishment. Thank you.